this is rotating with an angular velocity of omega. Means this is doing the rolling motion. So for the pure rolling, the point of contact. So this for this point of contact, first velocity will be in this direction due to the velocity of center of mass, and due to the rotation, if suppose r is the radius, so due to the rotation there will be tangential velocity in this direction of this point, that will be r omega. So for this point P, the condition for pure rolling will be velocity of point P with respect to ground is equal to 0. That is the condition of pure rolling. Many times I told you. Now, if this body having the acceleration of center of mass A and having the angular acceleration alpha, okay, and r is the radius. So at point P, the first acceleration is in this direction. Acceleration of center of mass. This is the acceleration of center of mass, and this will be means this point P will also have the acceleration of center of mass in this direction. But due to rotation, there will be another tangential acceleration that is equal to r alpha. Many times I told you. And for pure rolling, what is the condition? The acceleration of point P with respect to ground is equal to 0. Means you will get acceleration is equal to r alpha. And if here you will get V is equal to r omega. This is ground. And ground is at rest, we are assuming. If there is any platform, if the platform is also moving, then this condition will not work. V is equal to r omega. Okay. So remember, for pure rolling, you have to remember this thing. You have to remember this thing. With respect to the ground or with respect to the platform, the velocity of center or velocity of point of contact is 0. And for acceleration, you have to remember the acceleration of the tangential acceleration of the point of contact should be 0 with respect to ground. But here there will be centripetal acceleration will be all there. That will not equal to 0. Okay, so if this point is at rest, with respect to the ground, means if the velocity of this point P is 0, means this point is at rest with respect to ground. If this point is in rest with respect to ground, means at this point there will be no friction. So you can say that friction, very important point. Friction is not there. Why friction comes? Due to the relative motion. Here is no relative motion between point and ground, so there will be no friction here. So friction is not there. This is true for the horizontal surface. So this is a horizontal surface. This is the horizontal surface. So this statement is true for horizontal surface. Now today we will discuss the pure rolling on inclined plane. So there you will see there must be the friction for pure rolling. So pure rolling on inclined plane. Pure rolling on inclined plane. Suppose this is an inclined plane. I'm taking. This is the inclined plane. So this is the inclined plane. On this inclined plane, suppose there is a body, a symmetrical body is there. This body is rolling. This body starts rolling. Okay, starts rolling. And initially I am supposing this surface is a smooth surface. Okay, this surface is a smooth inclined surface. Smooth inclined surface. If this body is rolling down like this, so first we will see, we will try to find out what are the forces on this body. What are the forces on this body? Okay. So first force on the body will be in this direction, that will be mg sine theta. If this inclination is theta, that is mg sine theta, and another force is the normal reaction. So normal reaction will be like this. This is the normal reaction. This is the component of the weight, and on the inclined plane, the component of the weight along the surface is mg sine theta. And normal reaction, because of this contact, there will be normal reaction like this. Okay. So now you can see here, is there any torque on this body? And torque is only means torque is responsible for rotating the body. But here there is no torque, because this mg sine theta is passing from center of mass and is also passing from center of mass. No torque is there. If no torque will be there, the body will not rotate. The body will slip, or body will perform the translational motion only. If there will be no friction on inclined plane, then the body will not roll, it will translate. So you can write here inclined, for inclined smooth surface, for inclined smooth surface, body can only undergo translation. Body can only undergo translational motion. Okay. And the acceleration, if you will find, then you will get the acceleration of the body will be, acceleration of this point will be g sine theta. Having acceleration, g sine theta. And you can also say that here torque will be 0. Torque on the body is equal to 0. So there will be no rolling. Due to 0 torque, there will be no rolling. There will be slipping. There will be slipping only. So now it is proved that if there will be no friction force on the inclined plane, there will be no rolling. Why? Because torque, there is no force that can give the torque. Okay, another case we are taking, if we are taking the rough surface, this surface is a rough surface, rough inclined surface. Means if the surface will be rough inclined surface, there will be the friction on the body. Okay, rough inclined surface, rough inclined surface. Okay, so the forces on the body will be mg sin theta in this direction, normal reaction in this direction. Now the body will try to go in this direction. So the friction on the body will be in this direction. This will be the, on this point, means friction force on the body will be like this, now, because the body will try to go in this direction. The relative tendency means the body is moving in this direction, so friction opposes the motion, opposes the relative motion between surface. So friction will be acted in this direction. Suppose h is the height of this inclined plane. Okay. So what will happen? Now this force, one force is acted now. This is the friction force. This F is the friction force and mg sin theta is the component of the weight and n is the normal reaction. Now the body is performing translational motion due to this mg sin theta. But now there will be a torque due to this friction force F into R. If R is the radius of this body, then now there will be a torque. Earlier there was no force. You can see. Okay, now friction force is acting in this direction. Now, due to this friction force, there will be a torque F into R. So the body will rotate due to torque. What is torque? Turning effect of the body that produces a turning effect, means turn the body. So due to this friction force, there will be torque, and torque will turn the body, mean rotate the body. And translation motion is also doing, body is also doing the translation motion, and at the same time the body is turning also. So means there will be rolling. Now rolling will start. Okay, now we will write the equations of translational and equations of rotation motion of this body. So for translation of the body, see the body is going in this direction. So one force is this mg sin theta in this direction, and one force is friction force in this direction. So we can apply Newton's second law. Net force on the body is equal to mass into acceleration of the body. So what is the net force on the body? Mg sin theta minus F is equal to mass of the body into acceleration of the body. This is equation number 1. Have you understanding or not?
Yes, sir. Yes.
I have applied the Newton's second law. Net force on this body is equal to mass into acceleration of this body. So net force, some force is in this direction, some force is in this direction. Subtract both the force, you will get total force or net force, and that is equal to mass into acceleration of the body. First equation. Now, due to rotation, net torque on the body is equal to I alpha. This is the rotational equation. torque is equal to I alpha. Net torque on the body is equal to I alpha. So what is the net torque? F into R. Friction force into R. That is, and this is equal to I into alpha. From here, you will get the value of the friction force. You can find the friction force from here, I alpha by R. This is equation number 2. Now, if this body is performing the pure rolling, okay, so this is the condition. I am drawing the diagram again. This is the plane. On this plane, there is a body, and this body is rolling down. If this body is performing the pure rolling, so what should be the condition for acceleration? See, what should be the condition for acceleration? A is equal to R alpha, or acceleration of point of contact with respect to the ground must be 0. Okay, so this will have the acceleration. This body is having the acceleration A. Okay, I have written here A is the acceleration of the body in this direction. So in this direction, there will be one acceleration A, and the body is rotating also. The body is rotating with, suppose, the angular acceleration alpha. So due to that, there will be another acceleration that is equal to radius into alpha. So R is the radius. So for the pure rolling, A is equal to R alpha. Pure rolling. From here you can find alpha. So we will get A by R. Question number 3. So what you should do, you should put the value of F and value of alpha in equation number 1. Okay. Put alpha and F in equation number 1. So what is equation number 1? Mg sin theta minus F is equal to mass into acceleration So it will be mg sin theta, the value of the friction force, I alpha by R. I alpha by R, that is equal to mass into acceleration. Now we will put the value of alpha also. So it will be mg sin theta minus I alpha is what? A by R. So it will become A, and R multiplied by it will become R square is equal to MA. Okay, so you can write this like this. Mg sin theta is equal to MA plus IA divided by R square. So you can write, you can take A common from here. Okay, so it will be mg sin theta. You can take A common. You will have mass of the body, moment of inertia of the body divided by R square. Now from here you will get the acceleration of the purely rotating body, that is A equal to mg sin theta divided by m plus I divided by R square. So this is the acceleration in case of a body rolling on a plane surface, on an inclined surface. One more thing you can do, you can take m common. Okay, this is not our final formula. If we will take m common, so m will be removed from here, and you can do that like this. I divided by it will become mr square. So this m and m will be cancelled out. You will get the acceleration. That is g sin theta divided by 1 plus I divided by mr square. Okay. So this is the acceleration of the body doing the pure rolling on the inclined surface.
So,
Hmm.
in the last step,
Here.
how did R square become MR square?
Huh. Actually, na, I have taken. Okay, I'm removing this. I'm removing this also. What I did. This is mg sine theta. Okay. So what we have done. We have taken m common from here, and from here also you will take m common. Or in other way, you can say that multiplied by m and divided by m, and here is m plus I divided by r square. In this way you can think. So it will become mg. So if we will multiply it by m and we will divide by m, so there will be no changes in this equation. Okay, so this m is here. Now I am multiplying this m inside this bracket, so it will become m divided by m plus it will become I, and this m will be multiplied by r square, so it will become mr square. Now this m and m will be cancelled out, and this m and this m will also be cancelled out, so it will become g sine theta divided by 1 plus I divided by mr square. Basically directly I have taken their m common. Understanding?
Yes, sir.
So finally we will get this formula. Okay, after this is the acceleration. This is the acceleration of the body performing pure rolling. Acceleration of body doing pure rolling. On inclined plane. Okay. Now we will find the velocity of the body on inclined plane. Velocity of the body on inclined plane. So this body will be initially at rest. Initial velocity of this body is equal to 0, and we are interested to find out the final velocity of the body when it will reach bottom of the inclined plane. Suppose the body reached here, rolled down and reached here, and v is the final velocity of the body. V is the final velocity of the body. Okay, so what we can do? See this acceleration. G is constant, sine theta is constant, 1 is constant, moment of inertia of any body will be constant, mass of the body will be constant, radius will be also constant. So this acceleration is basically constant acceleration. For the constant acceleration, we can apply the equations of motion. So for the motion of this body, we can apply the equations of motion. Okay, so acceleration is constant for the body. So we can apply equations of motion. We can apply equations of motion. Okay, so suppose this distance from here to here, this distance is s. Okay, suppose this distance is s. So now from this triangle, you can find sine theta. So sine theta will be perpendicular divided by hypotenuse. So h by s. So s, you will get h by sine theta. Okay, now apply the third equation of motion. V square u square plus 2as. V square means v square, u square is 0 square because initial velocity of the body is 0, plus 2. What is the acceleration of the body? This will be the acceleration, na? G sine theta 1 plus I g sine theta divided by 1 plus I divided by mr square. So this is the acceleration, and into s. And s is h by sine theta. Now from sine theta and sine theta, this sine theta and this sine theta will be cancelled out. So velocity will be this will become 2 into g into h. This will become 2 into g into h divided by 1 plus I by mr square. So it will become, and here is the square also, you can write like this. V square is equal to 2gh divided by 1 plus I by mr square. Now v square is this, so v will become under root of 2gh divided by 1 plus I by mr square. So this will be the final velocity of the purely rotating body on the inclined plane. Write down please.
So both these cases are for pure rolling.
What?
These cases are for pure rolling.
What is these
Both
are
the-
the no. These are not the cases of the pure rolling. Basically, this is the velocity in pure rolling. So velocity in pure rolling. Earlier also we did this, and this is acceleration in pure rolling. Done? Okay.
So
This is for rough inclined surface. Okay. Actually, this is here.
Thought so.
Completed?
Yeah.
Done?
Yes.
Okay. Write down this.
Also.
Okay. So we have finded out the final velocity of the body and acceleration of the body. Now we will find the friction force, this friction force. So we have this equation number 1. So we will use this equation. So this equation we will put the value of acceleration, okay, and we will find out the friction. Okay, so this is equation number 1. So you can write from equation number 1, okay, so it is mg sine theta. We want to find this friction force. Mass into acceleration is g sine theta divided by 1 plus I by mr square. So we can find it will become mg sine theta minus mg sine theta. See, we want to find this friction force, so you can write this in this form. F is equal to, here is mg sine theta divided by 1 plus I divided by mr square, okay, and minus of this mg sine theta. So when you will take minus common, so you will have this F is equal to mg sine theta minus mg sine theta divided by 1 plus I by mr square. Now mg sine theta take common. Take mg sine theta common. So what you have 1 plus 1 divided by, now here you can solve this also. It will become I plus mr square, I plus mr square, and this mr is the mr square you have taken LCM, it will go here, so it will become mr square. Now further you can solve it, and here is not just a minute. Okay, so mg sine theta taken common, so it will be 1 minus 1 divided by 1 plus I by mr square. Okay, so now it can be written as mg sine theta 1 minus 1 divided by, it will become mr square divided by it will become mr square divided by mr square plus I. So you can take here mr square common LCM, so it will become mr square plus I. So it is mg sine theta 1 plus this mr square will go to the numerator, that will be mr square divided by mr square, here is minus sign, no? Here is minus sign, it will become mr square plus I. So it will become mg sine theta. Now take the LCM mr square plus I, so it will become mr square plus I minus mr square divided by mr square plus I. Now this mr square will be cancelled out, so you have mg sine theta multiplied by I and divided by mr square plus I. Okay, and here this is the friction force. This is the friction force. After this, you can write this friction. This is the value of the friction force. So this is the friction force. But whether this friction is static or kinetic, this friction will be, you will see here. As you can see, this point of contact is performing the pure rolling. This body is performing the pure rolling. So this point of contact will be at rest. And at rest, what is the friction? If the body is at rest, if what type of friction is there? Static friction. So static friction will be there. So this friction will be static friction. Static friction. Okay. So write down. So this is the friction force. And with this chapter is finished. And one or two numerical we will do. And after this chapter will be finished. This was very lengthy chapter.
Done, sir.
Okay.